If you're about to implement an asset management system or sitting through demos wondering what half of the terminology means, you're not alone. Enterprise asset management has its own vocabulary, and vendors throw these terms around assuming everyone knows what they mean. The problem is that nodding along when you don't understand the tech or the terminology leads to expensive misunderstandings. You buy a system expecting certain capabilities because you hear certain words, and then you discover those words meant something different than you thought. Or you miss asking critical questions because you didn't know what questions to ask. And really isn't your fault. You may be an accountant or purchasing person sitting through technical demos, and they're throwing around jargon. So these 10 terms will come up in every EAM conversation, every demo, and every implementation meeting. Understanding them won't just help you sound smart, but it will help you evaluate systems effectively, ask the right questions, and avoid the misunderstandings that derail projects. So the first term, a work order, is the fundamental building block of any asset management system. It's the record that captures what work needs to be done to which asset, by whom, what materials to use, and at what cost. Now think about work order as the documentation of a maintenance event. When a street light goes out, someone creates a work order. When a pump needs repair, there's a work order. When a vehicle comes in for scheduled maintenance, that's a work order. Every interaction between your maintenance staff and your physical assets should be documented through a work order. Now, why does this matter so much? It matters because work orders create the data that powers everything else. Without work orders, you have no maintenance history. You can't see that this particular, pump has been repaired 6 times in the past year, which might tell you it's time for replacement rather than another repair. And so without work orders, you have no cost tracking. You can't calculate how much you're spending to maintain a specific asset or asset class. Without work orders, you have no labor tracking. You can't see how your crews are spending their time or whether certain types of work are taking longer than they should. The discipline of creating work orders for every maintenance activity, even small ones, is what separates organizations with useful asset data from organizations flying blind. I've seen public works departments where the most experienced technician carries decades of maintenance history in his head. And when he retires, all of that knowledge walks out the door. Work orders are how you capture institutional knowledge in a system that doesn't retire. Term 2, preventive maintenance versus corrective maintenance. These terms describe the two fundamental approaches to maintenance, and the balance between them tells you a lot about how mature a maintenance operation really is. Corrective maintenance, sometimes called reactive maintenance, is what happens after something breaks. The pump stops working, so you fix the pump. The pothole appears, so you patch the pothole. The air conditioner fails, so you repair the air conditioner. You're responding to failures as they occur without any predictability. Now, on the other hand, preventive maintenance, often called PM, is what you do before something breaks, specifically to prevent it from breaking. Oil changes on vehicles, filter replacement on HVAC systems, inspections on bridges, exercising valves in the water system. You're performing scheduled activities based on time intervals, usage meters, or condition assessment with the goal of preventing failures before they cause problems. The ratio between preventative and corrective maintenance is a key performance indicator for any good maintenance operation. Reactive organizations spend most of their time on corrective maintenance. They're constantly fighting fires, responding to emergencies, fixing things that have already failed. Proactive organizations spend most of their time on preventative maintenance. They're preventing fires, catching issues before they become emergencies, and keeping assets in good working condition. Best-in-class organizations typically run 70 to 80% preventative and 20 to 30% corrective. Most government organizations I've encountered are flipped. 70% corrective, constantly reacting rather than preventing. So why does this matter? Because reactive maintenance is more expensive than preventative maintenance. Emergency repairs cost more than scheduled maintenance. And failures cause collateral damage and service disruptions. And assets that aren't properly maintained fail sooner, requiring premature replacement. The EAM system's job is to make preventive maintenance easy to schedule, assign, and track. If generating and managing PM work orders is cumbersome, crews don't do it, and you'll stay trapped in reactive mode. Third term, Asset life cycle. Every asset travels through a life cycle, from acquisition to disposal, and different decisions apply at different stages of that journey. The life cycle typically includes several phases. Acquisitions, when you buy or build the asset and it enters your inventory. Commissioning is when you put it into service. It's installed, tested, begins operations. Operations and maintenance is the working life, the years or decades when the asset performs its function while you maintain and repair it. Rehabilitation or renewal is when you make major investments to extend the useful life, a roof replacement of a building or a major overhaul on an engine, a relining of a sewer pipe. And finally, disposal is when the asset reaches the end of its useful life and you retire it, sell it, scrap it. Understanding where assets are in their life cycle drives strategic decisions. So early in an asset's life, you invest in maintenance to maximize useful life and protect your initial investment. Later in the asset's life, you're weighing rehabilitation against replacement. Does it make sense to put another $20,000 into this vehicle? Or should we replace it? At the end of life, you're making capital planning decisions. When should this asset be replaced, and what should we budget for its successor? A mature EAM system tracks life cycle stage and supports life cycle analysis. It can show you which assets are approaching end of life, which assets have had maintenance costs that exceed their remaining value, and which assets should be prioritized for replacement in the next year's capital budget. This life cycle perspective transforms asset management from a tactical activity, fixing what's broken today, into a strategic function, and this informs capital planning and long-term financial forecasting. Your CFO will love you for this. Term number 4, CMMS versus EAM. You're going to hear both of these acronyms used, sometimes interchangeably, but they refer to different scopes of functionality. CMMS stands for Computerized Maintenance Management System. As the name suggests, it's focused on managing maintenance activities, work orders, preventive maintenance scheduling, labor and materials, maintenance history, labor tracking. The core question a CMMS answers is what maintenance work needs to happen and did it get done? EAM stands for Enterprise Asset Management, and it encompasses everything a CMMS does while adding broader capabilities. Asset lifecycle management, capital planning, risk assessment, financial integration, condition assessment, strategic asset planning. So it's a lot larger than just maintenance management. So the core question EAM answers is how do we optimize the total cost and value of our assets over their entire lifespan? Now think of CMMS as tactical and EAM as strategic. CMMS helps you manage today's maintenance work efficiently. EAM helps you make long-term decisions about asset investment, replacement, and risk. So in practice, many vendors use these terms loosely, calling their product EAM when it's really more of a CMMS with a few extra features. While evaluating systems, don't get hung up on what the vendor calls it. Look at what it actually does. Does it just manage work orders and PMs? That's CMMS functionality. Does it support life cycle analysis, capital planning, and strategic asset decisions? That's genuine EAM capability. For organizations with complex asset portfolios, utilities, cities that have large infrastructure networks across multiple departments, the strategic capabilities of true EAM provide significant value. For organizations with simpler needs, CMMS functionality might be perfectly adequate. Term number 5, condition assessment. Condition assessment is a systematic evaluation of an asset's current state, not just whether it's working or broken, but where does it fall on a scale from excellent to failed. A condition rating might be expressed as a score from 1 to 5, or 1 to 100, or using letter grades. The specific scale matters less than the consistency of applying it. So what you're trying to capture is how healthy is this asset, how much useful life remains. Condition assessment matters because age alone doesn't tell you when assets need replacement. A 20-year-old water main in good condition might last another 30 years. A 15-year-old water main in poor condition might fail next month. If you're making replacement decisions based on age alone, you're probably replacing some assets too early and others too late. The mantra, oldest first for asset replacement sounds logical, but it's often wrong. What you actually want is worst condition first, replacing assets based on their actual state rather than just how long they've been in service. Condition assessments typically involve structured inspections using standardized criteria. So for pavement, you might use the Pavement Condition Index, PCI. For pipes, you might use CCTV inspection scoring. For buildings, you might use a Facility Condition Index, FCI. The specific methodology varies by asset type, but the principle is consistent. Systematic evaluation using objective criteria that can be applied uniformly across similar assets. So your EAM system should store condition scores, track how condition changes over time, and flag assets that have fallen below acceptable thresholds. This data feeds directly into capital planning. You can prioritize replacement projects based on condition rather than guessing based on age. Term number 6, failure codes. Failure codes are standardized classifications that describe why an asset failed. When you close a corrective maintenance work order, you're recording not just that you fixed something, but what the problem was, what caused it, what did you do to resolve it. So a typical failure code structure includes 3 elements. The problem code captures the symptom, what was observed. Examples might be leaks, noise, vibration, overheating, won't start, no output. The cause code captures why the problem occurred: wear, corrosion, contamination, improper operation, manufacturing defect, design flaw. And then the remedy code captures what was done to fix it: replaced component, repaired, adjusted, cleaned, rebuilt. So why go to this trouble? Why go to tracking all of these minute details? It's because failure codes transform individual repair events into organizational learning. Without failure codes, each work order tells a story. Pump wasn't working, fixed it. That's useful for documentation, but useless for analysis. You can't query stories. And think about what we've been talking about on AI. If you don't have data, if you don't have the right quality of data, no AI system is going to work for you on reporting. If you want to learn more about AI, click on this video. So without failure codes, you can't analyze patterns across the entire asset base. Show me all failures caused by corrosion across all pump assets. So without failure codes, you can analyze pattern across the entire asset base with failure codes. So with failure codes, you can analyze patterns across the entire asset base. For example, you can ask your future AI system, show me all failures caused by corrosion across all pump assets. Show me the most common cause of vehicle breakdowns. Show me which equipment has the highest failure rate for specific problem types. These patterns reveal systemic issues that aren't visible in individual work orders. Maybe you discover that corrosion is causing most of your pump failures, which points to a water chemistry issue that's damaging equipment. Maybe you find that a specific vehicle model has an abnormally high failure rate for transmissions, which influences your next purchase decision. Maybe you see that operator error causes a surprising number of equipment failures, which suggests a training opportunity. The challenge with failure code tracking is getting crews to use them consistently. If your code list is too long, 200 options, nobody's going to find the right one. If it's too vague, everything that gets coded as other, you won't learn anything useful. Most organizations find success within 15 to 20 options in each category, and they can be refined over time based on what's actually working, what appears in the data, and what you learn from that data. Term number 7, MTBF, mean time between failures. MTBF measures how long an asset operates between failures. It's a reliability metric that helps you identify which assets are problematic, which are dependable. The calculation is straightforward: total operating time divided by the number of failures. If an asset runs for 2,000 hours and fails 4 times during that period, its MTBF is 500 hours. High MTBF means that the asset runs a long time between failures. It's reliable. Low MTBF means that the asset fails frequently. It's a problem. And so why does this matter? Because MTBF identifies your problem children. If a vehicle has an MTBF of 30 days, meaning it breaks down roughly once a month, that vehicle is consuming a disproportionate share of your maintenance resources. At some point, the cost of constantly replacing it exceeds the cost of replacing it. MTBF also helps with procurement decisions. If you track MTBF by asset make and model, you can see which manufacturers produce more reliable equipment. Maybe one pump model has an MTBF of 2 years, while a competing model has an MTBF of 5 years. That reliability difference should influence your purchasing. Your EAM system should calculate MTBF automatically from work order data. If an asset has had multiple corrective maintenance work orders indicating failures, the system can compute how much operating time elapsed between failures. The catch is data quality. If failures aren't being logged consistently in work orders, your MTBF calculations may be meaningless. Term number 8, MTTR, mean time to repair. MTTR measures how long it takes to restore an asset to service after a failure. It's an efficiency metric that captures your responsiveness to problems. The calculation is the average time from when a failure is reported to when the asset is back in operation. If you track work order timestamps, when created, when started, when completed, MTTR can be calculated automatically. Low MTTR means you fix things quickly. High MTTR means repairs drag on. And this matters because downtime has costs beyond the repair itself. An asset that's down for 2 weeks causes more pain than an asset that's down for 2 hours, even if the repair work is identical. Service is disrupted, other assets may be strained, customers are affected, staff work around the problem inefficiently. When MTTR is high, it's worth investigating why. Several factors typically contribute to this. One is diagnosis time. How long did it take to figure out what's wrong? If technicians spend hours troubleshooting before they can begin repairs, that's an opportunity for better training or diagnostic tools. Availability of parts. Are common parts in stock, or does every repair require ordering and waiting for delivery? Long MTTR often indicates inventory management issues. Then there's also scheduling. How quickly can you get a qualified crew dispatched to the problem? Backlogs and crew availability impact response time. And looking at MTTR by asset type or by work group can reveal where your processes have bottlenecks. Maybe you repair pumps quickly, but vehicles sit in the shop for weeks. That pattern tells you where to focus improvement efforts. Term number 9, GIS integration. GIS, Geographic Information System. Integration that connects your assets to their physical locations on a map. For many organizations, particularly those managing large infrastructure, this integration is crucial. Let's consider a water utility. When someone reports a water main break, the first question is where? Not just an address, the specific location relative to the valves that need to be closed, other mains that might be affected, and service connections that will lose water. That spatial context is critical for a response. Or let's think about a street maintenance operation. When you're planning pothole repairs, you want to cluster work geographically so a crew can fix multiple issues in one trip, rather than going back and forth across the city. Good GIS integration means assets live on the map as their natural habitat, not as an afterthought. You can click on a location and see every asset. You can click on a location and see every asset there along with its maintenance history. You can click work orders by clicking on the map. You can run spatial queries. Show me all the valves within 500 feet of this location. You can visualize patterns. Which areas have the most service calls? Which pipe segments have the most breaks? Poor GIS integration means coordinates are stored in database fields, but there is no meaningful map interface. You can export to GIS as a separate step, but there is no interactive spatial experience within the EAM itself. For utilities and organizations managing linear infrastructure, GIS integration should be considered mandatory. For fleet and facilities operations where assets have fixed locations, it's less critical. Knowing that a truck is at the maintenance garage is probably sufficient without putting it on a map. Term number 10, capital versus O&M. This final term describes the fundamental financial distinction in asset management, the difference between capital expenditures and operations and maintenance expenditures. Operations and maintenance, or O&M, covers the day-to-day costs of keeping assets running. Labor for repairs, parts for maintenance, consumables, utilities. These are ongoing operating costs that hit your annual budget as they occur. Capital expenditures cover major investments that create or extend asset life. Purchasing new equipment, constructing new facilities, major rehabilitations that add useful life. These costs are typically funded differently, often through bonds, capital improvement programs, or dedicated reserves, and they are accounted for differently. Often they're capitalized and depreciated over time rather than expensed immediately. The line between O&M and capital isn't always obvious. Replacing a worn part is clearly O&M. Building a new water treatment plant is clearly capital. But what about replacing a roof? Is that maintenance or capital improvement? What about repaving a parking lot? What about a major engine overhaul that extends a vehicle's life by 5 years? These distinctions matter because capital and O&M compete for different budget pools. They require different approval processes and have different planning horizons. Your enterprise asset management system should be able to track both, and more importantly, should help you see the relationship between them. If you're spending $15,000 a year maintaining an asset that's worth $30,000, that's a signal. Maybe you should replace it rather than continuing to pour operations and maintenance dollars into something that's costing more to maintain than it's worth. Capital planning benefits enormously from good O&M data. When you can show the council that cumulative maintenance costs on the street sweeper fleet have reached the point where replacement makes more financial sense than continued repair, you're making a data-driven case for capital investment. You're making a data-driven case for capital investment rather than just asking for more money. Understanding these 10 concepts will help you ask better questions, evaluate systems more effectively, and have productive conversations with vendors, consultants, and your own staff. So now that you know the language, the next question is whether asset management should be part of your ERP or a separate system. To learn more, watch this video. Thank you.